Good morning. Okay, we're talking coordinate proofs. In this particular video, we're concentrating on step 2 and 3 in our problem. So in this case here, we're told that we have to create a sketch of a figure and put it on the coordinate plane. So here's kind of the rules that go with that. The first thing we want to make sure we do is we sketch the coordinate plane. Our first goal is to try to use the origin or as a vertex of our figure, so as a corner, or as the center of our figure, because its origin is the point 0, 0, which makes mathematics easy. Okay. Ideally, we want to place one of our sides of the polygon on the axis, so either on the x-axis or the y-axis. Again, it allows some stability in there. If possible, we want to try to keep everything in the first quadrant. All the values there, all the x values, all the y values are all positive numbers here, which makes things easy. And then we can also look at using symmetry about the axis. So if I can go positive and negative b, or positive and negative c, or positive and negative 3 off the x-axis, I keep thinking everything balanced that way is 2. So that's how we kind of place it on there. Second part then is to step 3, where we have to identify the coordinates. If you need to know how to do that, go back and look at part 1 of this video series. Okay, so let's try these. Here was part 1 type problems. Here's part 2 type problems. We have to position and label each triangle on the coordinate plane. We've got to stick this stuff on there, and we've got to tell us what the corners are. So an isosceles triangle, RST, with a base units of 4A units long. So I have to create a isosceles triangle, and we're going to call it RS unit. And it says that the base is RS. That tells me in this case that the bottom of my triangle is going to be RS unit. It's going to be RS. So that's where that's going to come in. So I'm going to put R right here at the origin, and I'm going to go across, and I'm going to say this point over here is S. Now I have that whole thing listed out there. I have to make an isosceles triangle. Isosceles triangles have 2 equal sides. So I'm going to draw this the best of my ability to make sure those 2 have equal sides. Now we're told the triangle is R, S, and T. Well, I've already used R and S. The top must be T. So I have it drawn on there. I've got a point at the vertex. I've got one of the sides on the x-axis. I got everything in the first quadrant. So I've clicked on all 3 of those first 3 points. Now we've got to identify the points. Well, R has to be at 0, 0. It's at the origin. A, or S, has to be 4A units away from R. Got to keep that in mind. Now we know S is on the x-axis, which means its Y value is 0. Now, if it's 4A units away from R, it has to be 4A in the X. So I've got that point taken care of. I have 2 of the 3 points. Now I got to do T. T is going to be directly above that line. That line is a line of symmetry for that triangle, meaning that line is going to cut the RS in half. So since the whole thing was 4A units wide, it means 2A has to be to the left and 2A to the right. So my X value of T has to be 2A. Well, now it's up off of the x-axis. How far up? I don't know. I'm going to use a variable, call it b. So T is at 2AB. And we've got that one done. Now, let's look at my second problem here. Call it problem 2. It's a right triangle FGH with legs. Legs are the sides that make up the right triangle that are A units and B units long. Notice A and B are 2 separate variables, so I want to make sure I use 2 different lengths. So I just need to make a right triangle, and the easiest way to do that is to do it right on the axis. I'm going to make one side go that way, make one side go this way, and I'm not going to let those 2 things be the same length, and then I'll put the diagonal in. Again, I've got one point right at the origin. I got the 90-degree angle at the origin to make things easy for myself. And then I've got 2 sides of this thing on an axis. So now we just need to identify them. So I'm going to call that F and G and H. And now we've got to determine what the points are. Well, A looks like a smaller, F looks like the smaller side. So I'm going to say that's the A unit side. So I'm going to say that one's A, and I'm going to say the bottom is B. So I can start clicking here and getting the points. Well, G is at the origin. It's 0, 0. H is on the x-axis, so its y value is 0. F is on the y-axis, so its x value is 0. Now we just got to figure out how we get the other parts. Well, when I look at it, from G to H, that side is B. Well, that represents the x value. From G to F, that length is A. That represents the y value. I got all three of these labeled. Let's look at the last problem here. It says we have an equilateral triangle, EQI, with a vertex of Q at 0A. I'm going to go ahead and put that point in right now. There's Q at 0A. And whose sides are 2B units long. I don't know how long 2B units is, but I know A is up there at 0A. So what I'm going to do is I'm going to make my equilateral triangle, all three sides the same length, and I'm going to do it in such a way that I use the y-axis as a line of symmetry. So that gives me an E on one side of this triangle and an I on the other side of the triangle, and they're both on the x-axis, which means their y value is 0. Now I just need to figure out what is their x values. Well, I'm told the length of this whole bottom is 2B units. Well, if the y-axis is a line of symmetry, it means I have to be B units to the left and B units to the right of that y-axis for my E and I, which means the I is going to have a positive B value going over, where the E, since it's to the left, would have a negative B value. So that's how did they phrase the directions? That's how we position and label a triangle on a figure.